Hello and welcome. My name is Dave Cranen and I will be your presenter for today. Today's presentation will be on NICET Level 3 Hydraulic Calculations, NICET Review of 15014 Example Loop Problem. Don't quit. When things go wrong, as they sometimes will, when the road you're trudging seems all uphill, when funds are low and debts are high, and you want to smile, but you have to sigh. When care is pressing you down a bit, rest if you must, but don't ever quit. There are certain assumptions that can be made when using the Hardycross method. Total flow into any point equals the flow leaving the same point. Also, the flow coming into the loop will equal the flow exiting the loop. This is called the principle of conservation of matter. Next, friction loss should be equal along any path joining 2 points, regardless of the path chosen. This is called the principle of conservation of energy. Thirdly, pressure. There will be one pressure where the loop splits and one pressure where the loop rejoins. Other key points to keep in mind when performing Hardycross include: label the direction of the flow, clockwise equals positive, counterclockwise equals negative. Do not lose sight of this direction sign as you perform your calculations. Next, calculations will begin with a guess of how the flow will split into a loop. Sometimes this first estimate will be so far off that it may be advantageous to forget about this initial guess and simply guess again. Either way, it helps you to move in the right direction to determine the flow. Hardycross method continued, example number 1. Here are the steps to follow when using the Hardycross method. 1. Number each loop and number each path. 2. Estimate the initial flow and assign the direction for this flow, negative, positive, etc. Calculate the pressure loss in each loop. Number 4. Add the pressure losses for all pipes in the loop, as well as the sum of the values for the friction loss divided by the flow. 5. Use the Hardycross formula to determine the correction factor needed to adjust your estimated flow. Step 6. Correct the flow estimates and adjust as needed. 7. Repeat until the desired accuracy is reached. Per Nfpa 13 requirements, this is plus or minus 1/2 of psi. The best way to understand this process is to work an example. We will work the same example problem used for the formula and hydraulic calculations form examples previously shown. A sample worksheet is provided to keep track of your calculations as shown on the following slides. We will be using a copy of this sample worksheet. Example 1, Step 1. Number each loop and number each path. In this example, this is a single simple loop. Path 1 starts at point B, flowing in a clockwise or plus direction and includes pipes B and C, pipe C and D, and pipe D and E. Path 2 starts at the same point, flowing in a counterclockwise direction or minus, and includes pipes BG, GF, FE. Step 2. Estimate the initial flow and assign the direction for this flow. As shown in the figure below, the flow into point B is 100 gallons. For starters, we will guess an even split and each path of the loop will flow 50 GPM. Okay, this is a sample form that we fill out, and this shows the first 2 steps, steps 1 and step 2. Step 3. Calculate the pressure loss in each path. This step requires knowing the friction loss per foot of pipe in order to determine the value for H, the head loss in pipe. From our friction loss tables, 1.5" Schedule 40 pipe with a flow of 50 gallons per minute has a friction loss of 0.088 psi per foot. You could also use the Hayes-Williams formula to determine the friction loss for each pipe segment instead of using the friction loss tables. What I understand is NICET requires us to use the Hayes-Williams formula. For path 1, pipe BC, H is equal to 0.088 times 50 feet or 4.4 psi friction loss. Pipe CD, 0.088 times 25 feet equals 2.2 psi friction loss per foot per total. Pipe DE, 0.088 times 50 equals 4.4 psi friction loss. The sum of the head loss for path 1 is equal to 11 psi. Are the steps in worksheet form. Our bottom line is AHF is equal to 5.7. Step 4. Add the pressure losses for all pipes in the loop as well as the sum of the values for H divided by Q, friction loss divided by the flow. The total sum for the head loss is equal to 11 plus minus 5.3 or 5.7. The total sum for HQ for path 1, this value will always be positive. Pipe BC is equal to 0.088. Pipe CD is equal to 0.044. Pipe DE is equal to 0.088. The total sum for HQ for path 2, a positive number. Pipe BG is equal to 0.046. Pipe GF is equal to 0.014. And pipe FE is equal to 0.046. The total sum of HQ for both loops is equal to 0.326. This is the worksheet for those steps. Step 5, using the Hardycross formula to determine the correction factor needed to adjust your estimated flow. HQ is equal to minus AHF divided by HF times 1.85. So with this, AQ is equal to minus 5.7 divided by 0.326 times 1.85 equals minus 5.7 divided by 0.603. AQ is equal to 9.5 gallons per minute. This is the correction factor that will be used to adjust the initial estimate for the flow rate. This is the worksheet for the steps. Step 6, correct the flow estimates and adjust as needed. Using the correction factor from the previous step, the flow will be decreased to 40.5 gallons per minute in path 1 and increased to 59.5 gallons per minute in path 2. This adjusted flow rate will then be used for the next round of calculation. This is the worksheet for this step. Step 7, repeat until the desired accuracy is reached. Per NFPA 13 requirements, this is within 0.5 psi. We will repeat the process starting at step 3 with the adjusted flow rates determined in step 6. Keep in mind that since the flow rates have been adjusted, the friction loss values will also change. Going back to step 3, calculate the pressure loss in each path. This will actually be step 8. This step requires knowing the friction loss per foot of pipe in order to determine the value of H, the head loss in pipe. From our friction loss tables, 1.5" Schedule 40 pipe with a flow rate of 40.5 gallons per minute has a friction loss of 0.06. You could also use the Hayes-Williams formula to determine the friction loss for each pipe segments. instead of using the friction loss tables. Therefore, path 1, pipe BC is equal to 3 psi, pipe CD is equal to 1.5, pipe DE is equal to 3.0. The sum of the head loss for path 1 is 7.5 psi. Step 9, calculate the pressure loss in each path. This step requires knowing the friction loss per foot of pipe in order to determine the value for H, head loss in the pipe, or PSI loss in the pipe. From our friction loss tables, 2-inch schedule 40 pipe with a flow of 59.5 GPM has a friction loss of 0.037 psi per foot. For path 2, keep an eye on the direction of the flow. Pipe BG is equal to 90 feet times 0.037. Pipe GF is equal to 25 feet times 0.037 or 0.925. Pipe FE is equal to 90 feet times 0.037 or 3 or minus, don't forget the minus 3.3 psi. The sum of the head loss for path 2 is equal to 7.585. This is what our calculations would look like on our worksheet. Okay, next, example 1 again. Add the pressure losses for all pipes in the loop as well as the sum of the values for H divided by Q. The total sum for the head loss is equal to 7.5 plus minus 7.6, which equals minus 0.1 psi. At this point, the pressure for both loops balances to within 0.5 psi, so we can stop the calculations at this point. So recap, flow for path 1 is equal to 40.5 gallons per minute, and flow for path 2 is equal to 59.5 GPM. This will give us a total of 100 gallons per minute. Pressure at point B is equal to 36.2 psi plus 7.5 psi for a total of 43.7 psi. At this point, we are close to solving the problem. Congratulations, you have completed the loop calculations using the Hardycross formula.